Welcome everyone. I'm Kaibi, and I'm happy to introduce Pawel. He's been Summer of Code students for 2 summers in a row, 2006 and 2007, working on MacLibre and OpenTouch. We had the opportunity to host him back in Europe in Hamburg during last fall, actually.
Yeah.
And now I'm happy to have him here in Mountain View to give a bit more detail on his project. So everyone, welcome Pawel.
Thank you very much. I'm really glad I can now see you here. So today I will give you just a short demonstration of the MacLibre project and the OpenTouch project, my both Google Summer of Code project. But before I start, I would like to give you just a short view at the city I came from. It's called Wrocław. It's actually I'm from Poland, and yeah, there's a lot of really nice places you can go, and the city it's the fastest growing city in Poland actually, and there's a lot going on even at today and during the night. There's a lot of events out there, so if you ever gonna have opportunity to be in Poland, just try to be in Wrocław. Say?
Those high dynamic range photos?
No. And so I'm from Wrocław University of Technology. I'm studying computer science out there at the Faculty of Electronics. So this building is pretty nice. It looks like cheese with these little holes. Yeah. So just to give you some quick look where I'm from and where I'm studying. So today I will be talking about 2 projects. First, the MacLibre one. I was doing during the Google Summer of Code 2006, and then the OpenTouch, which is right now just like in design phase because I will be doing this during this summer in 2007. So just a quick agenda. First, I'll talk about MacLibre. What is MacLibre? How does it work? What can we install with it? I will show you some screenshots, and I will talk about future work. And then I will switch to OpenTouch. I'll talk about multi-touch screens. What is it? How multi-touch screen works? And I will show you my hardware prototype of one of these screens. And then I will go through some software that's available to work with this kind of devices. And then I will describe OpenTouch concept and the modules inside. I'll show you some basic gestures and my range of duties for the Google Summer of Code, because OpenTouch is a really big project, so I won't be able to do all the work during only the summer. But I picked up some of the modules I will be working on. So yeah, let's start with MacLibre. So MacLibre is a new way of open source software distribution on Mac OS X. It was started at Google Summer of Code 2005 by Francois Perchef. He was working for WinLibre, a mentoring organization. And I was working at MacLibre 2 at Google Summer of Code 2006. So I did some bug fixes, some GUI improvements, and I bring MacLibre up to date. So actually what MacLibre is. So MacLibre is an open source software distribution for Mac OS X. It's simple, supposed to be simple, intuitive, with application that you really need. So it's just a selection of applications. So our main goal was the simplicity. So just like Albert Einstein said, make everything as simple as possible, but not simpler. So we kind of decided to go that way. So it's a software installer which supports the DMG images and zip files. There's a lot of, you can write your own container for other formats, but actually we're just thinking about only about binaries, just to have some sort of package management only on binaries. We don't want to go to source code and through all this compilation process. So the application is looking for the app folder inside of the DMG image or zip files. And based on that, it just copies the packages, it downloads to the application folder. There's also, I wrote a distribution generator so you can make your own MacLibre distributions, let's say Games Libre or Office Libre, or whatever you want to call it. It's just like a set of applications you want to distribute. And you can have offline distribution or online distribution. With offline distribution, you have everything inside your DMG image. With online distributions, the XML file with package descriptions is downloaded from the server, and based on that, based on XML parsing, and we build a package tree, and you can choose whatever software you want to install. So this is a simple. How does the XML file looks like? So after you download it, there's a distribution. Inside we have a category, so it's at least one by the distribution. Then there is a package, of course, at least one. Description inside, the home page of the package, and installation tag, file, and dependence for the optional, as an option. I will show you some basic. It's the old CyberDAG, but you can have a view. How does it look like? So there's the description, the home page, the installation, the size on the disk, the MD5 sum. We can say that, for example, this version is only for the Mac OS X, let's say 10.3.9, or this one starts from 10.3.0 to 10.3.8. And based on that, we built this package tree, so you can choose whatever you want to install. So yeah, what kind of applications we can install? Well, a lot of applications that are open source applications on Mac, for example, Firefox, Blender, Adium, Thunderbird or Vienna RSS Reader, VNC, iTerm, and Player. Yeah, so we are working on just a various selection of applications. We don't want to give user a lot of applications because he can. It will complicate his decision about choosing the right application he wants. So some quick screenshots. So this is the installation process, and that's how the MacLibre, the first screen looks like. And you choose the packages from the tree. Actually, the application is written in VX Python, not in pure Objective-C. Then you confirm your selection. You can have a break for a coffee or something while it downloads all the packages. And at the end, you have the summary, which applications have been successfully installed and which not, and why not. And yeah, that's the application. So right now, what we are working on is some translation, internationalization. I'm working on the Polish version. One guy is working on the Spanish version. There's also my mentor was from France, so he will be working on the French translation. Yeah, that's the translation part. What we are also working on is to create apps updates notification using Grow, so we can inform user about some new updates on the application he just installed. We're thinking about integration with Spotlight to create a plugin for Spotlight, so you can type in some application that is in MacLibre and just press enter and install it without any problems. We want to implement a Sparkle software update, so the update will be really easy to the new MacLibre version. And right now, we have to prepare those XML files alone. Just by myself, I have to do it by myself. But we want to create an automatic apps update tool so we can update the MacLibre XML file really fast using some, for example, the data from version tracker or Mac update. And we are also thinking about admin and maintenance tool for MacLibre, so we can do some fast editing of this installation XML file. And the last thing, what I just came up with is a MacLibre file system using MacFuse, which, well, it's just in my head right now, but what I wanted to do is to create sort of package distribution in your file system so you can go in MacLibre folder and have all these packages sorted by category, and just by copying the file on your to your application folder, you can have it's just an installation process. So yeah, I think that would be nice, but it's still work in progress, and just it's still in my head. Yeah. So that's just a quick overview of the MacLibre project. And now I would like to switch to OpenTouch, which is supposed to be open source framework for multimodal input devices. It's, like I said, it's in design phase. I will probably start working on the code in about 2 or 3 weeks. It's a project for Google Summer of Code 2007, also for WinLibre mentoring organization. It's more complicated. I will start with what actually a multimodal device is and how the multimodal interaction is described. So the multimodal interaction provides the user with multiple modes of interfacing with a system beyond just the traditional keyboard and the mouse. For example, the example device might be, I don't know how many of you are familiar with the multi-touch screens, but this is just an example device that can be used as a multimodal device, and that's what I want to use for the OpenTouch right now. So using the multi-touch sensing, we are able to invent actually the new kind of user interface, new user interaction techniques. And And for the multi-touch screen, what it actually is, the history, it's like in the 1990s, there was some design of multi-touch screens, but actually the CPU was so slow, so the image, it's mostly based on image processing, and the image processing was really slow on the processors out in the 1990s. So there was only a touch screen with the single point of contact, and right now, we have a lot of different devices for multiple points of contact, which is a multi-touch screen. And there was this researcher at the New York University, Jeff Hahn, who presented in 2005 a multi-touch screen based on FTIR technique, which stands for frustrated total internal reflection. And I'm doing my prototype based on this technique, which is really simple. I will show you in a minute how does it work. Of course, there are other techniques. For example, iPhone is using different technique. There's a React table, and of course, just released the Microsoft Surface, which also is based on some infrared cameras and the image processing. So how the multi-touch screen really works. So we have a hand, we touch the screen, and we can have multiple points of contact. So let's say we have a piece of acrylic and some infrared LEDs. And we the light from infrared LEDs shines into the acrylic, and the light inside just bounce inside. And whenever you touch the screen, the light is reflected, and we have a IR camera which has a pulse filter for the visible light, so the camera only sees the infrared light. We have a projector which shows our application on the acrylic, And the light from the fingers goes just to as an input to the IR camera. And as you can see on the image from the IR camera on this computer, we see some light, real light blobs. And using image processing, we can have the exact coordinates of those fingers. And based on that, we can do other stuff that we'll describe later. So my prototype, I just started with some LEDs, then with some testing. This is just the IR camera without the visible light filter, but you can see those really light blobs. There are some LEDs at the top. And yeah, when you touch the screen, there's an input for the camera. Then I created some aluminum frame and some circuit to make it look better. And right now it looks similar. This is just a screen with the LEDs. And of course, it's not all because we need the infrared camera, we need the projector. Right now I'm using some mirror to get a clean image on the multi-touch screen. Yeah, so this is my work. This is a work in progress, but actually that's how it looks like right now. Now it shows YouTube video out there. So of course, it's not just hardware. You really have to use. You need some kind of a software to control this kind of devices. So there are some projects that are available right now, so you can use with this kind of application, with this kind of hardware. The most popular one is called TouchLeap, which was written by one guy from New York. He's CEO founder of a Natural User Interface group, which is a community behind all the multi-touch technology. And he wrote this application about a year ago. And that's the most popular one. And a lot of students that are doing their own multi-touch screens use it. There are also some other, like a processing environment with additional blob detection library. And there's a VVVV with blob detection patch. These are the projects that you can use for some simple blob detection. There is this React Division, which is used with React table, interactive table. This is open source project. It's not actually a blob detection, but it might be used for multi-touch screens. And there is OpenCV library, which was released by Intel a couple years ago. It's an open computer vision library. They have a blob extraction library, which allows to extract blobs from the input image. So this is what we can use right now, and my goal is to create a new project which will look like this. So we have a multimodal input device on the bottom. We get an input image. An input device sends video to the nTrack module. nTrack turns video stream into blob coordinates and sends them to nCore module. And nCore converts the packets from those data structures to the OSC protocol. OSC stands for Open Sound Control, which is a protocol, message-based protocol. It uses UDP for sending packets. And then nCore calculates vars such as pressure, distance, and passes this to the gesture or passes input data straight to some client applications, if it is not a gesture such as X or Y coordinates. Then the N gesture receives data and runs gesture detection algorithms. And the end gesture actions are performed via, for example, Java virtual machine sockets or inter-process communication or AVT robot or any other specified API. And so engEDU is actually a library called from within the N core, and this allows us for extending engEDU into internal applications, allowing for different demo applications to have different gesture setups. So we can have use engEDU with the external applications, like for example Google Earth, to do some zooming like this or zoom out, or we can create our own internal applications. For example, some image gallery when we can move objects around and also do some zooming or some other type of gestures. So I'll go through all those modules. So the tracking module, which is called nTrack, this is a basic image processing. Techniques are performed on this camera output to identify the points of contact. And the computer vision techniques are used to interpret the motion of contact points as discrete touches or strokes. So nTrack will be responsible for tracking multiply input. And we will do the blob detection and tracking. This is what I'm going to do for the Google Summary of Code right now. But the nTrack also will be doing motion detection and tracking, so we can, in later development, it will allow us to create sensitive or interactive floors, so we can go through and there's some water effect or something like that. And also, we will have fiducial detection and tracking, and in this module, we have input device calibration. The second module, the N-core module, is in charge of the framework commands and settings. This, of course, includes calibration settings, also gesture module settings, chosen method of communication with internal and external applications. It also does some blob data processing, some calculations of those vars like pressure, like pressure, velocity, size, distance, acceleration. In this module, we have a framework configuration and settings and the OSC packet management, which is the open sound control protocol management. We can use a pure OSC protocol, or there is also a protocol on top of the OSC, which is TUIO. This is all for tangible user interfaces. Actually, for this, it's used for the React table that I was talking about before. So we can use both of them. That's the plan. And then there is the engEDU module, and will manage gesture conversion and recognition from a stream of data from the OSC messages from N-core, for example. Gesture recognition will be based on the shape comparison and certain vector changes. And so using the vector of 2 coordinates of the same finger between a couple frames, we'll be able to determine exact location and moving path of a finger. So what I want to do in gesture, I would like to implement a single point gestures and multiply points gesture, sort of mouse gesture, but using your own fingers. And the module will be also responsible for gesture actions handling and forwarding to the internal applications and external applications. And the basic gestures. Let's start with the rotating objects. We can do rotation using 1 finger stationary and the other pivot that pivots around, just like that. We can also do it with 2 fingers that pivot around their center of the gravity, just like, let's say, like that. We can move objects using 1 finger. We can move using 2 fingers. It just all depends on the configuration. We can select one object, or we can select multiply objects. We can draw a shape around some objects to select them. We can toggle the menu somehow. We need a gesture to toggle the menu, the system menu. And of course, there's a lot of more gestures. For example, zoom in and zoom out using 2 fingers, just like intuitive, just like on iPhone, using those 2 fingers to get a zoom in or zoom out. So for my Google Summer of Code, because the Google OpenTouch, like I just said, it's a really huge project, and this is my range of duties I will be doing for this year, Google Summer of Code. So what I want to do is I would like to do an image acquisition from IR camera. Then I would like to work on blob detection and tracking using a blob. There's a blob detection library written in Java. So I might use that, but I also found a really good paper about linear time component labeling algorithm using the contour tracing technique. So it will all depend on the blob detection results. And if that goes OK, I will probably use blob detection, but I might implement both. Then I will do some image filter to get the background separation so I can get a clean image of the fingers of the blobs. Then, of course, there's the OSC management. There's a lot of Java open source libraries that implements Open Sound Control Protocol. Then I will do framework configuration and the input of the camera and video samples and calibration of the screen, which it's not so easy. Then, of course, the blob data processing to get those pressure vars, the velocity, the x-y coordinates, and do the forwarding over the OSC protocol. And some basic gesture recognition based on those data that I got from the Anchor module. And, of course, that's all behind that. We won't see that. So we need some sort of demo application. For example, a simple image gallery, so we can show you how does it look, how the gesture works, how the blob detection works. So we need this demo application. I will try to do a simple image gallery which shows all the gestures and how the OpenTouch framework works. So here's some couple links for you. So MacLibre web page, maclibre.com. The OpenTouch web page, which is on my to-do list. It's not yet. I just got the domain, but the OpenTouch project will be at the opentouch.info. The natural user interface group at the www.nuigroup.com. This is this community I was talking about, community around the multi-touch screens and multi-touch sensing techniques. And there's also my MacLibre Google Summer of Code 2006 proposal and the OpenTouch Google Summer of Code 2007 proposal at my blog in PDF format. So thank you very much for attention. Any questions?
Question about MacLibre. Do you support uninstallation?
Well, not yet. Yeah, I was thinking about it, but right now I support just a reinstall. So you can reinstall application when you have a new version. But yeah, that would be a good feature.
I was just sort of wondering how it compares to like Faint or.
Well, it's supposed to be simple. Like try to have a normal user and tell him to install Faint. He'll be like, "Oh, could you install it for me? Because it's really complicated." And what I wanted to do is just a simple, intuitive application for normal, regular user, Mac users, so they can really fast install a new software. Yeah. But I think I will go the MacLibre FS way, so we can use the Mac Fuse, and that would be really cool. Any other questions? Okay. Thank you very much.